Today we are going to discuss enthalpy of neutralization. Enthalpy of neutralization. What is enthalpy of neutralization? The amount of heat energy heat energy is released when 1 gram equivalent of 1 gram equivalent of 1 gram equivalent of an acid of an acid reacts with reacts with 1 gram equivalent of 1 gram equivalent of base base. So this is the enthalpy of neutralization. Here acid reacts with base and forms salt and water. For example, HCl plus NaOH gives rise to NaCl plus H2. Okay, what is meant by gram equivalent? What is meant by gram equivalent? This is 1 gram equivalent of HCl. 1 gram equivalent of HCl. This is also 1 gram equivalent of NaOH to form NaCl and H2O. Okay, in this process, heat energy is released. In this process, minus 13.7 kilocalories heat energy is released, or minus 57.3 kilojoules heat energy is released. So, heat of neutralization is always exothermic reaction. Heat of neutralization is always exothermic reaction. So, what is heat of neutralization? The amount of heat energy is always released when 1 gram equivalent of an acid reacts with 1 gram equivalent of base to form 1 mole of water. For strong acid and strong base, for strong acid, for strong acid and a strong base, enthalpy of enthalpy of neutralization, enthalpy of neutralization is always constant, is always constant per gram equivalent, per gram equivalent of an acid, and a base. This value delta H neutralization is equal to minus 13.7 kilocalories per mole, or minus 57.3 kilojoules per mole, minus 57.3 kilojoules per mole. Okay, next example son, HCl plus NaOH gives rise to NaCl plus H2O. NaCl plus H2O. Enthalpy of neutralization is equal to minus 13.7 kilocalories. Okay. This is 1 gram equivalent. 1 gram equivalent. 1 gram equivalent. This is also 1 gram equivalent. This is also 1 gram equivalent. This is 1 mole of water. 1 mole, 13.7 kilocalories per mole of water. Okay, next reaction between H2SO4 plus 2NaOH gives rise to Na2SO4 plus 2H2O. This is 1 gram equivalent. 1 gram equivalent. 1 gram equivalent. This is also 1 gram equivalent. 1 gram equivalent. 1 gram equivalent. So, when you take 1 gram equivalent of sulfuric acid, 1 gram equivalent of NaOH, only you get 1 mole of water. 1 mole of water. So, enthalpy of neutralization is equal to minus 13.7 kilocalories. Okay. According to, okay, this is enthalpy of neutralization. And another definition of enthalpy of neutralization. The enthalpy change, the enthalpy change, the enthalpy change when 1 mole of 1 mole of water is formed from acid and base. Acid and base. Okay, H plus plus OH minus gives rise to H2O. Delta H is equal to minus 13.7 kilocalories or minus 57.3 kilojoules. So, for formation of 1 mole of water, for formation of 1 mole of water, 1 mole of water, heat of neutralization heat of neutralization is always constant. Is always constant. Heat of neutralization is always constant. Okay. For 1 mole of water. This is very, very important point. For example, this is very, very important. HCl plus NaOH gives rise to NaCl plus H2O. So here 1 mole of water is formed. Enthalpy of neutralization is equal to minus 13.7 kilocalories per mole. Minus 13.7 kilocalories per mole. 1 mole of water is formed here. Okay. And another example is H2SO4 plus 2NaOH. 2NaOH gives rise to Na2SO4 plus 2H2O. Na2SO4 plus 2H2O. Here, 2 moles of water is formed. When will 13.7 kilocalories energy is released? When will 2 into 13.7 kilocalories energy is released? Okay, this is 1 mole. This is 2 mole. Okay, here water is formed 2 mole. So delta H is equal to minus 2 into 13.7 kilocalories. If you take 1 mole of sulfuric acid and 2 moles of NaOH, you get 2 moles of water. For 1 mole of water, you will get 13.7 kilocalories. For 2 moles of water, we will get 2 into 13.7 kilocalories per mole. You understand? If you take 1 gram equivalent of acid, 1 for suppose 1 gram equivalent of acid, this is 1 gram equivalent, this is 1 gram equivalent, 1 gram equivalent, this is 1 mole of water. 1 mole of water, delta H is equal to minus 13.7 kilocalories. If you take 1 gram equivalent of acid, 1 gram equivalent of base, you will get only 1 mole of water. In such case, enthalpy of neutralization is equal to minus 13.7 kilocalories per mole. In this case, okay, if you take 1 mole of H2SO4, 2 moles of NaOH, we will get 2 moles of water. So here we will get 2 into 13.7 kilocalories per mole heat energy. If you take 1 gram equivalent of acid, 1 gram equivalent of base, you get only 1 mole of water. This is the difference. Okay, please write down. And another example is reaction between NaOH and phosphoric acid. 3 NaOH plus H3PO4 gives rise to Na3PO4 Na3PO4 plus 3H2O. Delta H is equal to minus 3 into 13.7 kilocalories. Why? This is because here 3 moles of water is formed. Here 3 moles of water is formed. That's why 13.7 kilocalories per mole energy is released. Okay, when if you take 3 moles of NaOH, 3 moles NaOH and 1 mole phosphoric acid, you get 3 moles of H2O. If you take 1 gram equivalent of NaOH, 1 gram equivalent of NaOH and 1 gram equivalent of phosphoric acid, you get 1 mole of water. You get 1 mole of water and energy is 13.7 kilocalories. Energy is released. Energy is released. Okay. Have you observed difference? Okay. If you take moles, heat energy is released according to balanced equation. If you take gram equivalents, heat energy is released according to unbalanced equation. 1 gram equivalent of acid, 1 gram equivalent of base always produces 1 mole of water. 1 gram equivalent of acid, 1 gram equivalent of base, strong acid and strong base always produces 1 mole of water. Okay, enthalpy of neutralization is constant, 13.7 kilocalories. If you take moles, heat energy released according to how many moles of water is formed in balanced equation. Okay, here taking moles, 3 moles of water is formed. So heat energy is released according to balanced chemical equation. If you take gram equivalents, 1 gram equivalent of acid, 1 gram equivalent of base, always forms 1 mole of water. Okay, this is called enthalpy of neutralization. Next, enthalpy of neutralization of enthalpy of neutralization of strong acid versus weak base, or strong base versus weak acid, or weak acid versus weak base is always less than is always less than 13.7 kilocalories or 57.3 kilojoules. If you take if you take strong acid or weak base, or weak acid or strong base, or both weak acid and weak base, enthalpy of neutralization is always less than 13.7 kilocalories per mole. Why? This is because of enthalpy of ionization. This is because enthalpy of ionization. What is enthalpy of ionization? Weak acids are not completely ionized. Weak acid or weak base are not completely ionized. Since these are weak, okay, since these are weak. So, when you take weak acid or weak base, 1 mole of water is not formed. 1 mole of water is not formed. Since they do not ionize completely. But in a reaction, in a balanced chemical equation, 1 mole of water is appeared. If 1 mole of water is appeared, 13.7 kilocalories must be released. Okay. But heat of neutralization is less than 13.7 kilocalories. This is because some amount of heat energy is utilized for complete dissociation of weak acid or weak base. Using this heat energy, weak acid is completely dissociated. Using this some energy, weak base completely dissociation. Once weak acid or weak base completely dissociated, 1 mole of water is formed. But energy is liberating energy is less than 13.7 kilocalories per mole because some energy is waste. That energy is called enthalpy of ionization. For example, acetic acid CH3COOH plus NaOH gives rise to CH3COONA CH3COONA plus H2O. Enthalpy of neutralization is equal to minus 10.7 kilocalories. Here 1 mole of water is formed. If 1 mole of water is formed, enthalpy of neutralization is 13.7 kilocalories. But how much energy is released? Only 10.7. But what about remaining 3 kilocalories energy? That 3 kilocalories energy is utilized for ionization of weak acid completely. Acetic acid is weak acid. Acetic acid is not completely ionized. If it is not ionized, 1 mole of water is not formed. So, enthalpy of neutralization is less than 13.7. But here acetic acid is completely ionized by consuming some heat energy. That's why enthalpy of neutralization is 10.7 kilocalories if you take weak acid or weak base or both. So, enthalpy of ionization is equal to enthalpy of ionization of weak acid is equal to minus 13.7 kilocalories. Okay, this is heat of neutralization of strong acid and strong base. Okay, minus enthalpy of neutralization of enthalpy of neutralization of enthalpy of neutralization of enthalpy of neutralization of weak acid versus strong base. Okay, so enthalpy of neutralization. Enthalpy of neutralization of enthalpy of neutralization of weak acid plus strong base, strong base plus enthalpy of neutralization of strong acid plus strong base. For example, weak acid, weak base enthalpy of neutralization minus 10.7 minus enthalpy of neutralization of strong acid and strong base minus 13.7. That is equal to minus into minus plus 13.7 minus 10.7. That is equal to 3 kilocalories. That is equal to 3 kilocalories. Okay. So enthalpy of ionization is equal to enthalpy of neutralization of weak acid plus strong base. Weak acid plus strong base minus enthalpy of neutralization of strong acid plus strong base. Strong acid plus strong base is always constant 13.7. Okay, this is minus 10.7 minus into minus plus 13.7 minus 10.7, that is equal to 3 kilocalories per mole. 3 kilocalories per mole. Do you understand? This is called enthalpy of ionization. Okay. Next. 1 gram equivalent is equal to 1 gram equivalent is equal to 1000 milli equivalents. 1000 milli equivalents. Gram equivalents is equal to gram equivalents. Gram equivalents is equal to weight divided by equivalent weight. Weight divided by equivalent weight. Milli equivalents is equal to milli equivalents is equal to weight divided by equivalent weight into 1000. Weight divided by equivalent weight into 1000. Milli equivalents is equal to weight divided by equivalent weight into 1000. Okay na? Gram equivalents is equal to gram equivalents is equal to normal T into volume in liters. Milli equivalents is equal to milli equivalents is equal to normal T into volume in ml. So these formulas are used when solving problems regarding heat of neutralization. Okay, such formulas are used during problem solving of enthalpy of neutralization. This is enthalpy of neutralization. Okay, you understand? For example, find enthalpy of neutralization of 500 milliequivalents of acid reacts with 200 milliequivalents of base. 200 milliequivalents of base. Okay, HCl plus NaOH gives rise to NaCl plus H2O. Acid 500 milliequivalents, base 200 milliequivalents. Okay, for 1000 milliequivalents, heat of neutralization is 13.7 kilocalories. Here limiting reagent is NaOH, only 200 milliequivalents. So 200 milliequivalents. For 200 milliequivalents, what is the heat of neutralization? About 200 into 13.7 divided by 1000. This is 5 times. Therefore, heat of neutralization is 13.5 kilocalories. Okay, so heat of neutralization for 1000 milliequivalents is always constant. Here, now you should not take 500 milliequivalents because base is only 200 milliequivalents. Acid 500 milliequivalents, base is only 200 milliequivalents. So you have to solve problem by taking 200 milliequivalents only. Base quantity is less. Okay. బేస్ తక్కువగా ఉంది కదా, బేస్ తక్కువగా ఉంది అక్కడ, యాసిడ్ ఎక్సెస్గా ఉంది. నువ్వు అప్పుడు ప్రాబ్లం దేన్ని పెట్టి చేయాలి? బేస్ని పెట్టి చేయాలి. యాసిడ్ వాడతాం. యాసిడ్ బేస్లో 200 milliequivalents, యాసిడ్లో 200 milliequivalents రెండు కంబైండ్ అవుతాయి అక్కడ. 1 milliequivalent ఆఫ్ యాసిడ్ combines with 1 milliequivalent of base. 1 milliequivalent of acid combines with 1 milliequivalent of base. Up to 200 milliequivalents of base combines with 200 milliequivalents of acid. You understand? Remaining 300 milliequivalents of acid not involved in the reaction, not involved in the process. Okay.